Welcome to my final lecture for CSIS 201. It's on a topic I care a lot about and I think a lot of people are interested in. It's my views, or really, well, I don't know. Yeah, I guess it's my perspective on the intersection between science, reason, and religion. It's a question that comes up, I think, a lot in, this modern world, or if you study the natural sciences at all. How do we incorporate both science, reason, and religion all together, if at all, right? So depending who you ask, you'll get many different points of view on this. I'm going to offer up mine. Again, this is just for your sort of benefit. If you don't agree with me or something like that, that's fine. But I've studied this sort of topic a lot, and hopefully what I have to say will be useful to you. Oh, naturally it doesn't go to the next slide. There we go. So let's talk about sort of the modern world. The values of the Enlightenment, which was established 400 years ago, really set up two ways of knowing what is and isn't true. Reason, that is, logical conclusions based upon principles or axioms, and science. And by science, I really mean repeatedly testing theories through experimentation and empiricism. So, reason is a world of pure thought on one hand, and science on the other hand is sort of data driven by our observations of reality. And hopefully these two things sort of supplement or complement each other. But that's basically the premise of our modern world. At least how we think, how really sort of modern man, if you will, thinks of how to determine what is and is not true. The person on the left is Aristotle. He's often given credit as the first person who formally studied logic. He lived in the 4th century BC in Greece. On the right is Sir Francis Bacon. He's usually credited as the first person to have developed the scientific method. So he was very big on empiricism and really sort of helped kick off the Age of Enlightenment. And he has a wonderful sense of style as well, as you can tell. But with this perspective, you might start to wonder, and I think this is a question for a lot of people, where does faith fit in this? Where does religion fit into this? Is it just some personal thing? Does it really have is there any space left for it to talk about what is and is not true? And before I start teasing this all apart, I just want to give some credit to where credit is due. Science is an incredibly valuable tool that's enriched humanity and individuals' lives, and these are just a few examples. So you have the double helix there of DNA, a representation of our solar system, the splitting of atoms. We have that's down the bottom. I think that's the Faber process for making nitrogen, pulling nitrogen out of the air. Maybe I'm wrong. I'm not a chemist. I can't quite remember where I got that picture from. But anyway, chemistry has been an incredibly valuable science to humanity. The pasteurization process. So this is a way of disinfecting things. Most notably milk. There's, if you look at the population graph of the Western world before and after pasteurization, there's a big spike in human population after Louis Pasteur thought of this. And it's really saved a lot of lives. And in the center is the replica of the first transistor. So computing. And it's done a lot for us as well. So just giving some credit. Oh, and then in the top left, that's the cosmic background radiation of the universe. That's basically as far out as we can see or measure at all, in every direction from Earth. So that's, I'll come back to that if I don't forget later. And then reason. So I'm gonna tackle sort of reason first and talk about, well, it's of course important. I'll just say that. Of course, it's important to be logical, to come up with correct conclusions based upon, true facts. And there's a long history of, philosophers and mathematicians and logicians that we can draw from. There's a classic statue, the thinker there. The guy on the top right is Immanuel Kant, a great philosopher. Bottom right is Leibniz, a great mathematician and philosopher. Both of these people are actually quite strong Christian believers and wrote a lot about the faith. And then in the center is the guy from The Princess Bride. He kind of fails at reasoning, if you've seen that movie. This is a joke for myself. I'm just going to make jokes for myself throughout this presentation and just laugh at them. So enjoy. So I'm going to connect this all up with computer science and statistics. Those are my two areas of formal training and interest. So let's step back for a second to how long does it take to solve a problem? This is going to be really important for when we think about logic and what is and isn't provable. But let's just stop and think about how long does it take a computer to solve a problem? So we have hardware on the left. On the bottom, that's Charles Babbage's difference or analytical engine, which is technically a full computer, incredibly slow. It's not even a floating point operation per second, versus that is, I forget the name, but it's at Oak Ridge National Lab. It's at one time, maybe a couple years ago, was the fastest supercomputer in the world. So there's a hardware of how fast it can think, so to speak. But there's the other half is software. So the code, the algorithm itself, that really, those two things together are what really dictates how long a problem is going to take to solve. And sort of before knowing about computer science, you would think, well, maybe the most important thing is the hardware on the left. It is important, but actually we'll find out it comes down to the software. So what do I mean by that? I have a little snippet of code there for finding the largest thing in the list. So basically we're going to look at, well, can we write a program to solve any old problem? And how easy or hard are they? Well, some problems are very easy. For example, finding the largest value in a list of numbers. I've asked you to do this during the course. You've more or less succeeded. But it's an easy problem. Why do I say that? Well, you have to go through each and everything in the list, right? And you have to, you fundamentally have to go through and look at each value. But it's just a for loop, right? You just start at the beginning, walk all the way to the end, and you just remember the largest thing you've seen. Easy enough. The code's short, it runs fast. Why does it run fast? Well, you have to look at everything, but the number of steps, basically the number of loops you need to go through in that for loop, is the same as the size of the list, right? So if I say here's a list of 100 numbers, you have to go through 100 sort of iterations of that for loop. If I give you 1,000, you have to go through 1,000. What that means is it takes a linear amount of time. So that makes that problem in general solvable. So for any list I can give you, you can write a program that's basically going to be able to find the maximum value in that list Yeah, the time goes up as the size of the list goes up. So if you have a list of 10,000 numbers, yeah, it'll take that much longer. But it's still sort of reasonable. So that's what makes a problem easy. If it comes down to something, it doesn't have to be linear. It could be polynomial. So it could have a like n squared, x squared sort of shape, right? That's still also okay, it turns out. But what about, are there problems that are much harder than this that we just can't get around? I'm going to show you, it turns out, yes, there's a lot of problems like this. I'll show you one example. This is one of my favorite deceptively difficult problems. It's called the traveling salesman. So imagine you are a salesman. Let's say you're based out of Portland, like this depicted in this picture, and you have a list of all these cities you want to visit to sell your goods. You want to go and visit all the cities and end up back where you started, in Portland. So not only do you want to visit each city just one time, but you want to take the shortest sort of circuit through all of them, right? You don't want to waste time zigzagging back and forth across the country. You want to minimize, the distance traveled, because that's going to go the fastest and it's going to be the cheapest and all of that. This is actually an incredibly difficult problem, believe it or not. And why is that? If you look down here at like the Colorado area, hopefully you can see my cursor, it's not clear always what's the next. If we're starting in Portland, maybe, this is Olympia, that makes sense. Boise, okay, I'll go over to Helena, great. Salt Lake City. These are all sort of the closest choices. It's not always clear that you should always go to the next closest place. Like, why not jump down here to New Mexico? Why not zig over here to Oklahoma? See, we have this sort of crazy pattern in here. Like, why not go from, this is Alabama to Mississippi? Well, we got to zig all the way up here. Or why shouldn't we go from Ohio over to Indiana instead of West Virginia? It actually turns out there's no easy way to come up with this tour or circuit of all the cities in general. And so there's no way to sort of easily see the answer, and there's a lot of possible solutions. So in general, if you have n cities, let's say you just have 10, the number of possible solutions, if it's 10, is 10 factorial. Well, the number of 10 factorial is like 3.6 million. So even for a small number of cities, the number of potential solutions, so the potential ways you could go around the country, goes up at just an astonishing rate. And yeah, there's some clever ways of solving this problem, but it doesn't help that much. It goes from a factorial down to exponential, which is still a big problem. This comic then says, well, you can really solve it by just like outsourcing it to someone on eBay. Yeah, again, I'll just laugh at my own joke. But anyhow, so if we look at a graph of, well, if we have 5 cities on our list, okay, the time's reasonable, 10 is reasonable, 15. When we start getting into the 20s and 30s, there's so many different ways of traversing 20 or 30 cities in general, the time just starts to rocket up. And there's nothing we can really do about it. So that's what the problem of exponential time is. Then, well, okay, this is at 30. You can see the graph is climbing rapidly. What if we wanted to say do this instead for like 20 cities in the USA? What if we wanted to find the optimal way of visiting every town, city, and village in the world? There's about 2.5 million towns, cities, and villages. Well, 2 raised to the 2.5 million. That's a really big number. There's a lot. It's going to take a long time to solve this problem. So what I'm saying here is we can have code that solves the problem. We can give it small instances of the problem, like 5 cities, 10 cities. It'll run. If you say, here's 1,000, here's 10,000, here's 100,000, here's 1,000,000 cities we want to find the optimal route for, you have it on your laptop, you have it on your supercomputer, you hit go, it never comes back with the answer. You'll just wait, and you'll wait, and you'll wait, and you'll die, and your children will die, and like your grandkids. That just sounds really morbid, but the whole, eventually the sun will burn out, and you'll never have the answer. So it's more, the amount of time it'll take is more time than anyone has. So that's a problem. It's a really big problem. And that's why computers haven't really just solved every problem we have, is because there's some that just are just too hard even for a supercomputer. And it's based upon the nature of the problem itself. So actually, in computer science, we bin up problems into ones you can solve kind of easily, like finding the largest number in a list, sorting a list of numbers, finding the shortest path from A to B. You can think like Google Maps, making change. Yeah, there's a whole list of things we can solve in a sort of a reasonable amount of time. And there's a lot of other problems we just can't. So like factoring numbers in the primes. So they use these little tricks, these problems that we can't solve. So this is how, like, when you buy something off of Amazon, say, how it keeps your credit card information safe when it gets transmitted over the internet. It gets encrypted. Well, how can something be sort of unbreakable in terms of cryptographically? Well, they're using a problem that's not really solvable in a reasonable amount of time. That's how they hide it in there. But then the trick is, the problem is solvable if you have the right key. So Amazon can see your credit card info, you can see your credit card info, but no one in between. Anyways, there's a bunch of other problems that are very, very hard, like finding the perfect chess strategy. Someone did finally manage to do this for like the 8x8 or whatever the size of a chessboard is. In general, it's not solvable if you add one more column or one more row. My favorite, stealing as much as possible from a house. That's a 0-1 knapsack problem. Traveling salesman problem, which I already mentioned. And then there's this other one called 3SAT. Well, it's 3SAT. 3SAT is sort of a funny computer science way of saying deductive reasoning, so logic. So it turns out logic is in one of these, in general, in this unsolvable problem category. So how's that possible? So let's take a look at this. Logic, sort of the basic sort of chaining together facts and rules to reach a conclusion. This is also called Modus Ponens. This is sort of a famous little quote here. So if you have this rule that all men are mortal, and Socrates is a man, that's a fact, I guess. And then the conclusion is Socrates is mortal. So you're applying that general rule to the specific of Socrates and coming up with the correct conclusion. And we have Socrates there on the right, and he's dead, so it all works out, right? But in general, this is how we think of deductive reasoning, is you have some facts, you have some rules, you apply your rules to your facts to come up with conclusions, and you just repeat until you either find a true statement, or you can't make that logical chain of inference. Then the question you've asked must be false. So if I depict this sort of visually, I have Socrates as a man, as a fact. I'm representing that as like a circle or a node in this, and then I have this sort of arrow over for applying the rule all men are mortal, and I come up with this other sort of new conclusion: Socrates is immortal. Now, the problem comes into, well, what if I have more rules? So what if I have all men are mortal, but all men pay taxes? Well, then I can come up with different conclusions, like Socrates is mortal or Socrates is poor. Political commentary aside, is depending upon which, if I'm trying to wonder, if I'm asking the question, is Socrates mortal, I have to know which rule to apply. And it's not always obvious, especially as I add more rules, which ones I need to apply. So more generally, I can have some fact, a ton of rules, and a ton of different conclusions I can reach by applying these. But what if I take a conclusion and then treat it as a fact, and repeat the process. Now we're in this world of, you can see how even using a small set of rules and a small set of facts, the number of conclusions we can reach grow, and it grows rapidly, and it grows exponentially, in fact. And it turns out there's no real way of getting around this fact. Lots of people have tried. It's basically proven that there's no way of dealing with the sheer sort of scope of all the things to consider. So again, just like the traveling salesman, we have this sort of wall we hit in terms of time. So as you increase the number of facts, the number of rules, the time it takes to answer a particular question goes up and up and up and up exponentially, and you just hit a point where you stall out. So you can basically reason about a few things, but you can't sort of include everything. So basically this is a problem for, say, mathematicians. As they're applying, you could think math is sort of the rules, and they have sort of theorems of things they've proven, and then they come up with more theorems, and each theorem is a fact. Well, there's a problem here, that they might not have enough time to reach every true mathematical statement just based on computational power, right? Even if there's an answer out there, they might not be able to walk from where we are mathematically, say, or logically, out to some conclusion. There's so many things to consider. It's this sort of needle in a haystack style problem. They might never reach it. So it just turns out, interestingly enough, that reason, including like mathematical sort of proof, is subject to this problem where the more things we consider, the longer it takes to reach new conclusions, and we just hit a wall. So what if we had an infinitely powerful computer? Could this help us? Surprisingly, the answer is also no. So now this is from a field of mathematics related to computer science called number theory. It's also where we get cryptography from. There's this guy. His name's Gödel. Now he's got umlaut in there. I don't really know how to pronounce it, so don't quote me on that. Maybe it's a go. It's some weird sound. Sorry, German people. Gödel. He's actually Austrian, but whatever. He's actually the greatest mathematician of the 20th century. He's pretty widely regarded as such, or at least he's in the top 5 or something like that. He's an incredible mathematician, and what he came up with is, when he's thinking about mathematical theorems and proofs, it's that we have some things we know are true, we apply some logical reasoning, come up with more things we know are true. That process of theorem proving, well, there's actually a theoretic problem, that there's some true statements about math and logic that don't have any corresponding proof. Now, going into he proved this mathematically, which was really sort of clever. He actually represented mathematics within mathematics to make this sort of proof. It's sort of esoteric, but if you want to read more about it, there's this great book called Gödel, Escher Bach, An Eternal Golden Braid, and it's actually about how that proof is related to mathematics and art. And it's sort of an incredible book. It's 800 pages. I'm actually ways through it. I'd probably be done with it if I didn't have so much grading to do, but personal problems aside, it's an incredible book. But really, it comes down to, if we go back to the sort of tree view of deductive reasoning, that there's just some true facts out here, the red circle, that there's no sort of linkage to where we started. And he proves this will always be the case. It's sort of an astonishing proof that doesn't get talked about near enough, so I always try to bring it up whenever I can. But basically, the conclusion of this is there's truth with no proof, and we're certain of this. It's not even really a question. Gödel basically proved that's the case. And we can actually, so that's the theoretical, but then again, we also have the more empirical side coming up from computational intractability. That is just taking too long. So there's this actual sort of double strike against reason and mathematics that if we had, basically we don't have enough time to possibly work through every proof that we need to discover everything that's true. And even if we did have a good starting place and enough time, we still couldn't theoretically reach everything because there's some things that are sort of disconnected, if you will. Sort of astonishing. Even if you cheat and say, well, the stuff we can't reach, that's true, let's just include that as like an initial assumption or something like that. Gödel still proves there's yet things even outside of reach, and it will always be that way. It's really sort of astonishing. So that's one half of the modern mindset is, well, reason. And it has this double hit of, well, we don't have enough time, and even if we did, we couldn't kind of come up with every true conclusion that is out there. So there is for sure truth with no possibility of proof. Which hopefully that alone to you is sort of a little bit astonishing. It's not as astonishing when I tell this to people who are in the humanities. They're like, oh, of course. But when I tell this to like an engineer or a scientist, they're like, holy smokes. So I hope you're more in the holy smokes camp, but we'll see. But what about the other half? What about science? What about science? Again, I'm just going to laugh at my own joke. This little Monty Python, he's trying to use scientific reasoning to determine if this poor woman's a witch. It's anyways, it's not exactly accurate, but science is sort of the other half, right? It's fundamentally data driven. So in a scientific framework, you're going to have a theory and then run an experiment and test it versus the data you gather from the experiment. And ideally repeat this process. And as you repeat this, you become more confident that your theory is true. So it's fundamentally data driven. So if reason itself is limited, well, maybe we can just collect enough data, right? Maybe that's the alternative is, well, science is great. It's more recent, so to speak, in human history. Maybe that's the real cool kid. And if we just get enough data and run enough experiments, we can figure out everything that is and isn't true. There's actually a problem with this. So this is related to my interest in statistics. There's this thought experiment. It actually is related to this sort of famous philosophical problem called the problem of induction, because science being data-driven is an inductive form of reasoning. There's this wonderful book. This is probably in my top 5 favorite books called The Black Swan. I recommend it to everybody. It's incredible. What's the Black Swan? What is the problem of induction? The more readily accessible version of this and rememberable version of this is, let's just pretend you're a turkey on a farm. Now, this is, of course, sort of ironic that tomorrow's Thanksgiving. So you're a turkey on a farm. And every day the farmer brings you some food and you're hanging out with your turkey friends. And this goes on day after day. You can sort of imagine your sense of, is this a good situation? Do I like it here? That's kind of on the rise. Everything looks good. Your day-to-day experience, the data, if you will, that you're collecting about the circumstance you're in, checks out. It seems great. It's sort of reinforcing your notion like, hey, maybe this is fine. There's nothing wrong. Well, this goes on for a while, and you can see on day 1001 that turkeyness index or happiness drops to 0. And why is that? Because the turkey got made in Thanksgiving. So the interesting part about this is, if you're the turkey, the data you can gather, your evidence, it's incomplete. And it's sort of radically incomplete, and actually is so incomplete, it's pointing in the wrong direction. The data says everything's fine. In truth, everything's not fine. It just hasn't been revealed yet. And it's that pivot point when the turkey gets made into Thanksgiving, that's what Nassim Taleb, the author of The Black Swan, calls the Black Swan. It's this sort of event that's improbable. It might not have any preceding evidence, but has a massive impact. So in the life of the turkey, of course, this is catastrophic. It's sort of, when I read this book, it was sort of a mind blower to me, coming from the world of statistics, that you think more data equals you're learning more, but that's not necessarily the case. So is this just here's the picture of this man's beautiful goatee, Nassim Taleb, personal hero of mine. But anyways, scientific discovery, it's only possible if we were getting a good sample of data, if you can reliably collect data, and that's not always true. It's not always true because the world is so complex and so chaotic. This generates events that are incredibly rare and difficult to predict, or maybe even impossible to collect any data for, which means the past does not always predict the future. That's basically the conclusion of that book, that the data we can gather does not always point us to the truth. It doesn't always tell us what's going to happen in the future. And it's because there's these incredibly complex relationships in reality that we just can't break down. And it's basically related to the same issue as 3SAT, logic and reasoning, that we basically can't break down that problem to anything simpler. We just have to go through everything to look for our answer. And so there's a list. So it's not just a thought experiment. There's a lot of things that really count as black swans, and I've even lived through a few of them. So the most recent would be like the 2008 financial crisis, the 9/11 terrorist attacks. So both of those, the 2008 crisis, everyone was saying, you know what, the economy is going up, the housing market is going up, there's nothing to worry about. And the first signs when it started to falter, people were like, oh, this is just a credit crunch. It's not a big deal. They started making up terms like credit crunch. It's nothing. Don't worry about it. And then, poof, the economy fell out. And that was the same way with the Great Depression, back in 1929. There's the Roaring '20s beforehand. Everything looked great. Everyone was a turkey. That's the moral of that story. Everyone was a turkey, and right around the corner, everyone got made in Thanksgiving. And that's happened several times. Sort of tragically, the 9/11 attacks, if you were alive then, which if you're in my class, you probably weren't. But this keeps happening over and over. These are sort of negative ones, like World War I is another one. If you were in Austria in 1914, well, that was one of the pinnacles of civilization at that point, is a place of culture, wealth, scientific understanding of an unprecedented level. And right around the corner, the next year, was the most destructive war in human history. And basically there's this sort of radical disconnect between what everyone thought was going to happen and what actually did happen. And again, it's because of these sort of chaotic, sort of hard to understand connections and realities. Like World War I started because Archduke Ferdinand was assassinated by this Serbian, I think, and then because of all these chains of alliances, it ended up being this sort of fringe political event. Got sort of, more and more countries got sucked into it. It sort of got upgraded into a whole world war. So something that was a small, sort of localized incident became the largest war the world has ever seen, only to be outdone by World War II a few years later. So again, it wasn't predictable. No one saw it coming, and it really shattered a lot of people's perception of the modern world. But there's a lot more of these, even positive things. A lot of human inventions. The story's almost cliche of, oh, someone discovered something by accident. That just happens over and over again. Like penicillin was this way. The internet was sort of this way, where no one really saw that coming, yet has this enormous impact all these events I'm talking about had enormous impact without much prior, if any, indication. And I guess we're kind of living through another one now, right? COVID-19. I remember sitting during the summer of 2019 preparing for the fall, thinking, wow, next summer my life's going to be great because I'll have all this much more experience, I'll have sort of everything ironed out, teaching's going to be so much easier. Nope. No one saw this coming, right? And it's because, again, we live in a world that's highly interconnected. So a flu breaks out in China, it's all around the world in a matter of a couple months. That's astonishing. And it's because of the complexity of the world we live in. And that complexity is only increasing, and the black swan will only come more and more often. So, the name, by the way, comes from Europeans thinking every swan was white until they went to Australia and saw, well, there's one that's black. Right? It's just a very simple version of the same idea, that their experience reinforced their belief, but it didn't really point to what's true. So, again, I mean, science is valuable, but there is this caveat, and it doesn't get brought up enough. So, together, putting these pieces together, contributions of a few computer scientists, Kurt Gödel and Nassim Taleb, we have, on one hand, reason has the double whammy of computational complexity, so you just run out of time, and a theoretic limit to everything mathematical, proven by Kurt Gödel. And on the other hand, science. Well, not everything is discoverable scientifically. The past does not always predict the future. Sometimes data is just misleading. That idea actually goes all the way back to Plato 2,000 years ago. He doesn't get enough credit for this. So there's, in the two main ways of knowing what is and isn't true, there's these two big caveats. Both of them have big caveats. So right there, to me, when I sort of discovered all this opened up a lot of sort of space, let's say, for the possibility of faith, the possibility of religion, the possibility of maybe there's some other things that are true we can't just get to through just science and reason. And to tell you the truth, I never was fully on board this sort of modern worldview, because it sort of denies the human experience. Like, is there really nothing else we can, would that really be it? Does it seem reasonable to think that all the other aspects of life can't convey to us what is and isn't true? It's just science and reason. That never sat well with me. But there is these issues. Can personal experience be trusted? Because it is subjective. You can't repeat these anecdotes. Something happens in your life is not necessarily repeatable, so you can't. So you don't know if it's coincidence or not, or something like this. And sometimes experiences can be just straight up misleading. You think, just like the turkey, you think the situation you're in is good, really turns out it's not. I sort of noticed something, though. Listening, oddly enough, to the radio, I was listening to this classic rock station, and they said, we're not going to play, we're going to depart from the top 100 and go to something a little off the beaten path. We're going to play this song. It's like from 1974, and it only made it to, the 106th spot on the charts or something like that. And the song was really bad. It sounded like 70s rock, but it really wasn't good. And I just had this revelation that, like, every time you listen to, classic rock, it always boils down to like a list of like 50 songs or something like this. And every time you turn on like a classic rock radio station, or it's basically just one playlist. It's one Spotify playlist, and that's it. What does that have to do with truth? Well, what had happened is there's a refinement. We kind of forgot about the music from the 70s that was just kind of crappy and just kept the hits, right? And it's really not even just 70s rock. You think about classical music, we only kept really good stuff. There's a lot of people, writing music in the Baroque era, for example. We only remember a handful of these people. So we got Bach there. The Who's on the right. That guy's jumping way high in the air. It's kind of astonishing. Hope he doesn't do the splits. Bach is over on the left. Basically, there's this process in human experience, really tradition itself. We tend to whittle out and forget the things that aren't useful, that don't matter, that aren't insightful. And we tend to keep the things that are. So in this top center of Shakespeare, it's the same thing. He wrote some incredible works of literature 400 years ago, but the thing is, there's a lot of other people doing it at the same time. But we somehow managed to keep his works and not the other people. And I don't think it's an accident we ended up with his works and not these other folks, because people consistently find meaning and insight in what he wrote. And this process of time sort of forgetting, time and human sort of tradition forgetting what's not useful and keeping what is useful, it's called the Lindy effect. And I'll explain this a little bit. Oh, and then bottom left, we have Socrates, who of course came up with the Socratic method of teaching, which we still use today. So that's thousands of years old. Bottom right is the band Spinal Tap. This is a joke. That doesn't really do anything with anything, but it's a fun movie. The point is, human tradition has a way of maintaining what is true and maintaining what is useful and maintaining what is good and sort of dropping everything else. And we can see that we've sort of maintained the best from the past when we start looking into the other things from the past, a little more obscure. And really, it turns out what the Lindy effect is for ideas, things that are more permanent. The best predictor of how long they'll last and stay around for is how long they've been around for. So if a book has been in publication for 10 years, you expect it to be in publication for 10 more years. If people have been listening to classic rock for 40 years, they're probably going to listen to it for another 40 years at least. If we've read Shakespeare for 400 years, people are still likely going to be reading Shakespeare 400 years from now. And just like Socrates, people have been teaching through the Socratic method, asking questions for a couple thousand years. Probably in a couple thousand years, assuming everything, civilization doesn't collapse, they're still going to be teaching through the Socratic method. So this idea of the Lindy effect and the preservation of truth through human tradition comes out of another book by Nassim Taleb called Anti-Fragile. And he really points out that the real power of science is actually the repetition of tests. So the fact that you have a theory and you test it over and over and over and over, that's where it comes, the truth of it comes into play. That, well, if something is held up for a long period of time, that is a large number of tests, you have more confidence that it's true. Also in part because it will have been exposed to more potential black swans. And he makes the claim that, the value and truth of a tradition, that can also be tested. And that's tested in the lives of the people who follow that tradition. And each human life that follows it is its own test. And if that tradition maintains itself over centuries, over millennia, really that's a series of tests over time, just like the testing of a scientific hypothesis. So he really concludes that the real test of truth is the test of time, and that is essentially it. And I sort of realize this connects to this passage in Scripture. And it says, "You will know them by their fruits. Do men gather grapes from thorn bushes or figs or from thistles? Even so, every good tree bears good fruit, but a bad tree bears bad fruit. A good tree cannot bear bad fruit, nor a bad tree bear good fruit. Every tree that does not bear good fruit is cut down and thrown into the fire. Therefore, by their fruits you will know them." And I think that is a reflection of this idea that someone's beliefs, their tradition they follow, the religion they follow, their values, is really tested in their life. The evidence should be in their life. And if that maintains, as Taleb points out, over centuries, over millennia, that points to those beliefs being true. And putting it all together, so I just final comment that the value and truth of a person's belief, I'd say it's evidenced, it should be evidenced in their life. And that's what this passage is saying. So putting it all together, how do I really view the world? And this is sort of my personal philosophy. I think all three things are important. So basically science and empiricism, logic and reason, and then tradition and human experience. And sometimes they overlap and sometimes they don't. So when it comes down to wanting to know how best to live, I think this is found in tradition. Basically, you should follow sort of the traditions, the paths, the beliefs that have held up for a long time, that have promoted human flourishing for a long time. The intersection between sort of tradition, human experience, and logic and reason, I'd say this is like morality and ethics. It has sort of morality and ethics has sort of still has to have a starting point, and then from there you can apply reason to come up with new conclusions. Now there's some things that are purely in the realm of logic and reason, for example, like abstract math, number theory, cryptography. Number theory, in fact, was a branch of mathematics that was intended to be purely abstract with no connection with reality, but they sort of failed in that it does have connection with reality, so oops. But there are realms of thought in terms of math and logic that are just purely in our minds. Now this intersects with science and empiricism, so like physics would be a good example here, that physicists have strong mathematical models of reality, and then they test it against reality with experiments by gathering data. And then there's some things that we can really only understand through just testing empirically. So like my research involves artificial neural networks. They're not really well understood theoretically or mathematically. It's really, if you look at the research, it's just people running a lot of empirical tests. Oh, that one works better. What if I change this design? Oh, that works better, with vague intuition of why. And then also like the field of like thermodynamics, originally that was developed just purely based on empiricism, looking at temperature changes. So it's purely data driven that they came up with that sort of branch of physics, or at least originally. And then there's some intersection, I'd say, between human experience and sort of empiricism. So, or rather between tradition and empiricism. I'd put like commerce and the markets in here, where there's a lot of data to observe, but also human behavior comes into play a lot. So try to understand that aspect of reality is really an intersection between those two things. And what I put in the middle is honestly just like God. That these three things really come together for us to have a better understanding of reality and really the creator of reality. So in view of this, the limitations of both science and reason, I come to this conclusion that if you want to live rationally, it really comes down to the question. The original question in a lot of old Greek philosophy was, how do you live? How do you live the good life? And they don't mean good by fun or something, but how do you live the most significant life or the most meaningful life or something like this? How should you live? Was the question that a lot of old philosophers thought about, and I think it's still relevant now. And I answer this in light of everything I've told you about, that if you want to live rationally and rightly, you should really follow the beliefs and practices that have guided people to a flourishing life as evidenced over centuries and millennia. And to me, this is pretty obviously the Christian tradition. It's been around forever. It's produced an incredible civilization. It's produced, Gothic cathedrals and spaceships and, incredible works of theology and philosophy and literature and on and on and on. That really the evidence is there in history. And tradition itself is a means to access the truth, and it points to the truth of our values. And I also just like I say, here it mentions a flourishing life. What is that? I think Aristotle answered it well when he says a flourishing life is really realizing your inborn potential, your God-given potential, and acting on it and doing something with it. And that goes back to that parable of the talents, which is another one of my favorite passages in Scripture. So to me, the sort of values and tradition that lead individuals to realizing their own potential, to their God-given potential to its fullest, has been, the Judeo-Christian tradition. And so that's essentially my justification for faith. Is sort of bottom up. It's sort of strange I come to this through statistics and computer science and esoteric mathematics, but that's just also sort of the history of my learning and thought. And hopefully that's useful to you. There's a lot of people question faith today, but I would say, if you want evidence of God, for evidence for why a religion is true, why our faith is true, I'd say the evidence is in the individual lives. That's the place to look. It's in individual lives over time. It's in the fruits, right? It's in the works of individuals who are truly trying to live out their faith, and you can look at the long history of people following that. I think that it speaks strongly to the truth that is in our faith. So hopefully this encourages you, gives you something to think about. Hopefully this is useful to you. If you have any questions about this, it's just one of my favorite topics to discuss. Hopefully this was sort of edifying and useful to you. Have a lovely break. Bye-bye.